Thank you so much for joining us, and in this video we are going to review Spring 2024 exam questions. Now I'm starting from question 2. Question 1 will be the last question that we are going to go through. So let's start here. Now let's look at first question here. Here we want to find limit as x is approaching 0 from the positive side. So from the positive means that all the values of x are greater than 0, and that is where we can find a function here. So the function is going to be this one. So we are going to write this one as limit. We are going to write this one as limit x is approaching 0 from the positive, and we are going to use the function x squared plus 5, and this is going to give us 0 squared plus 5, because here I'm going to set x to be equal to 0, and this is going to give us 0 plus 5, and this is equal to 5. So that's what we are going to get for the first one. Now the second one is when x is approaching 0 from the left side, meaning that all the x values are less than 0 because of this minus here. So it means that x less than 0, and you are going to use this function here. So this is going to give us limit x is approaching 0 from the negative, 7 minus 2 cos pi x, and I'm going to set x to be equal to 0, and I'm going to have this one to be limit x is approaching, we are setting this one to 0, so we are going to have 7 minus 2 cos of 0. And what is cos of 0? Cos of 0 is 1, so we are going to have 1, and this is 7 minus 2, and this is going to give us a big 5. So now let's look at C. Find limit as x is approaching 0 and justify your results or your answer. So this one here, limit as x is approaching 0 of f of x is equal to 5. Why? Because A is the same as B. So this is 5 and this is 5. So to justify the result, we are going to say that since limit x is approaching 0 from the negative of f of x is the same as limit x is approaching this one from the positive of f of x is equal to 5. So because of this is the same as this and is equal to 5, this is also equal to 5. So this is what we are going to get for question 2. Let's look at question 3. Now question 3, we want to find limit as x is approaching 1. So as I said, always do direct substitution first, but this one is a rational function, so we are concerned about this one, the one at the denominator. So now when I plug in 1, I'm going to have this one to be 0. So the only thing that I can do here is try to simplify. Now this function is the same as limit x is approaching 1. On the top here, I have x term here. There is no constant term on the top. So it means that I can factor something like x out. And I can also see that all the coefficients are divisible by 2. So I can also factor 2 out. So I'm going to factor 2x out, and it will be left with x squared plus 4x minus 5 divided by, then denominator is going to give us x plus 1, x minus 1. We can also try and simplify the top, and then we can cancel some of the terms out. So we are going to have limit x is approaching 1. Now x squared plus 4x minus 5 is the same as x plus 5 x minus 1 when you use factorization. So we are going to have 2x, x plus 5, then x minus 1 divided by x plus 1 and x minus 1. So when I do that, then this is going to cancel this, and I'm going to have this one to be limit x is approaching 1, then 2x, x plus 5 divided by x plus 1. And now that I have cancelled some terms out, I'll try and do direct substitution by setting x is equal to 1, and this is 2 times 1, 1 plus 5 divided by 1 plus 1, and this is 2 times 6 divided by 2, and this is going to give us 6 right there. So that's what we are going to get for question 3a. Let's look at question 3b. So as I said, direct substitution first. So let's do first set x to be equal to pi, and we are going to have cos pi plus sine pi on 6, and this is going to give us cos pi is -1 plus what is sin pi on 6. Sin pi on 6 is half, so you are going to have this one to be half, and when you do the subtraction you are going to have -1/2. So here you should be very good with unit circle here to see that this here is equal to half. It's very, very important here. So this is very important. And then this one too, I think this one will be the cosine graph, which will tell us that this is equal to -1. Good. And let's look at this one, and this is x is approaching infinity. So we need to think about horizontal asymptote or the slant asymptote. So now let's look at this. We can write this one as x is approaching infinity. So since x is approaching infinity, we need to pick the one with the highest degree, right? And ignore the rest of the terms. So I'm going to pick 3x squared divided by x squared, and I'm going to ignore the terms, right? Because of infinity, this is going to dominate. So this is the same as limit x is approaching infinity, 3 divided by 1, and this is the same as limit x is approaching infinity of 3. And since 3 does not depend on the x, this is going to give us 3. Now, another way that we can do this one is checking that the degree of the top, right, or the numerator is the same as the degree of the what? The denominator. So if that's the case, then we can say that we are going to find the ratio of the coefficient of this, and this is going to give us 3 also. So either you go by this or you go by this. They are all correct. So that's what you are going to get for question 3C. Now let's look at question 4. So question 4 is multiple choice. So let's try and figure out what this is equal to. So limit t is approaching -5 of 6 gen of t divided by f of t minus 5. This one, because it's multiple choice, you can just do it straight without showing any way of solving it, but I'll do both. Now this is the same as picking limits on the top and then limits at the down, right? So we are going to have something like 6 limit t is approaching -5 of gen of t, sorry, and then divided by limit t is approaching -5 of f of t minus limit t is approaching -5 of 6. So when I do that, this is going to give us, now this here is -2. So I'm going to have 6 times -2 divided by, this here is 10. So I'm going to have 10 minus limit of a constant is the constant, so -6. And this is going to give us -12 divided by, I think 4. And this one should be giving us -3. So this is what we are going to get here, and the answer is going to be this. But here, if you want to just do it straightforward without going through the whole of this, because it's a multiple choice, then know that this, you can just write it like this. This is the same as, so what I'm going to do here is, since this is gen of t, I look for the one with gen of t, and then I just plug in this. So gen of t, this is going to give us 6 times -2 divided by, I look for the one with f of t, which is 10, and this is going to give us 10 minus 6, and it's also going to give us the same thing here. So, but if it is kind of, we need to solve, then we need to go through this process to come and get the -3 here. Now let's look at this. Now this one, we need to use the squeeze theorem, because the function that we are looking for is actually in between this and that. So now let's try and figure this one out. So we have f of x here, which is here, but we see that we are picking limit as x is approaching pi on 2 on this. So we are going to do the same thing. We pick limit as x is approaching pi on 2 on this, and this, and we figure out the term. So let's do that. Limit x is approaching pi divided by 2 sine of x less than or equal to limit x is approaching pi on 2. Then we have f of x less than or equal to limit x is approaching pi on 2, and then we have x minus pi over 2 cubed plus 1. So let's try and simplify this. We are interested in this and that, right? So let's do this. Now, when I plug in pi, I'm going to have sine pi over 2, and sine pi over 2 is 1, right? Sine pi over 2 is 1, sorry. It's 1, so I'm going to have less than. So this is going to be limit x is approaching pi over 2, f of x less than or equal to. Then here, when I plug in pi on 2 here, I'm going to have pi over 2 minus pi over 2 to the power 3 plus 1. And this term here will go to 0. So I'm going to have this one to be also 1 here. And I'll have this function right in the middle here of f of x. So this is 1 and this is 1. So it means that this limit in the middle is also going to be 1. So we are going to have it to be c from there. Now let's look at question C. Now we want to, which of the following technique would allow you to evaluate this? So this one, since we have the rational function, which is the root here, then we need to think about the conjugate, right? So this one is going to be C. We need to just use the conjugate to do this. Yes. Now let's look at question 5. This is also true or false question. Now let's try and see what's going to happen here. Now, if f of 2 is equal to 3, then it must be true that this is 3. Oh, this is a big false, because if this one is 2, sorry, if this one is 3, it doesn't mean that this one too should be 3. This one can be 4 based on the function given to us, right? So this is not always true. Yeah, it is true that this can be 3 and this one too can be 3, but the question is saying that it must be true. So it means that this is false. Now let's look at this. Limit as x is approaching 5 from the positive is 1, from the negative is 1. Then this is equal to 1. Yes, this is true, right? Because the left and right are the same. So the original function should be 1, 2 as well. Let's look at C. If limit as x is approaching 1 from the negative is infinity, then f of x has a vertical asymptote. Yes, this is true, right? So since this is giving us infinity, so it means that if I have 1 here, then when I'm approaching this from the negative side, I'm going to this. So it's going to be an asymptote. You cannot cross. So this is true, even though we don't know what the left is going to approach, whether it's going to be going positive infinity or negative infinity. We are still going to have x is equal to 1 here to be equal to vertical asymptote. Now let's look at D. Now limit as x is approaching 3 of f of x does not exist, then this must be undefined. This is false. This is also false. If the limit does not exist, it does not mean that this one must be undefined, right? It can be that the limit does not exist, meaning that the left and the right are not the same, but the function this exists. So that's basically how the thing is. So this one is going to be false. Now let's look at the last question under true or false. Now the question is saying that if the position of an object is given by this, then the instantaneous velocity of the object at t is equal to 2 is given by the limit as x is approaching 2. So this one is good for you to be writing. Limit x is approaching 2 of the average rate of change f of 2 plus h minus f of 2 divided by h. So here, the only problem here is, anytime you are talking about instantaneous rate of change, you see that the function depends on h. So here the answer is false, because now x is approaching 2. The function has no x. The function here should be h approaching 2. So if this one was talking about h approaching 2, then this one could have been right or could have been true. But since x is approaching 2, it means that this is going to give us a false statement. Because for us to talk about instantaneous rate of change here, since this is h, then this should be h. If this one was x, then this one is true. So this is going to give us false here. Let's look at question 6. Let's look at question 6. Now, I love drawing graphs. Now, as soon as I see a graph, I try to do the easiest part. So the easiest one is f of 2 is equal to minus 2. So let me assume that I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. I have minus 1, minus 2, minus 3, minus 4. So f of 2 is minus 2. So f of 2 is minus 2. We are going to have it somewhere here, right? So I'm done with that one. Now let me go for the one where x is approaching finite value. So I have minus 1, I have minus 1, I have 2. So let me go for minus 1 first. So minus 1 from the left and minus 1 from the right. So from the left is minus 3. So from the left, where is minus 1 from the left? Minus 3. So I'm going to have it somewhere here, opened, but from the left. So I'm going to have some small tail here. So I'm done with this one too. And then this one from the right is 4. So from the right is 4. So I'm going to have it somewhere here, but from the right, so I'm going to have some tail here, right? Good. So I'm done with this one too. And let's look at when we have this. So this is telling us that since we are not having left and right and it's giving us 1, automatically we have limit x is approaching 2 from the left of f of x to be the same as limit x is approaching 2 from the right, and they are all equal to 1. That's the reason why we have this. Without this, we cannot have this. So anytime you have a limit like this, it means that the left and the right are the same and they are all equal to 1. So it means that at s is approaching 2, I'm going to have something here, and I'm going to have from the left and from the right. So I'm also done with this one. Now, x is approaching negative infinity, and it's giving us 2 is a horizontal asymptote. So we are going to have a horizontal asymptote here, right? So because x is approaching infinity. So that's what we are going to have. And we are done with this one too. But now the last one here says that when x is approaching infinity, then this must go to negative infinity. So we need to look for the x values before we can know where we can sketch this graph. So the x values are s is equal to 1, minus 1, and s is equal to 2. So x is equal to 2 will be the upper value, right? Because we have x is equal to minus 1 and x is equal to 2. So if on the normal line, if I have minus 1 and 2, then I cannot draw the graphs that this x is approaching infinity. X will be approaching infinity after 2. So it means that it should be after 2. And after 2 is this one right here. So now let's see how it's going to happen here. So let's see how we can join the graph. So 1, this graph here is coming to the right, and this one too is going to the left. So they should meet, right? So I can do this one like this. Can have this one to be catching like this. And then we said that if x is approaching infinity, it should be going to negative infinity. So this is basically going to approach infinity, but it should be going negative infinity. So it means that we need to go down. So this is going to give us down like this, right? Then this guy here is going to, so we are done with this one too. So we can just make this guy also be moving up like this. Good, because it's going to the negative infinity. So that's basically how the graph is going to look like, which is very nice. Now this one, we can just leave it open because we don't have anyone. The question is not telling us whether f of minus 1 is either 4 or minus. It can be this, or it can be in between anyway. So we can just leave it this way. We are done because there is no information telling us anything about f of minus 1. So we can just leave the graph this way and it is right. Now let's look at question 7, and then finally we are going to look at question 1, and then we are done. Now we have the graph. We want to figure out the solutions, right? So we have 6 questions here. So f of 2 plus the 2 from the positive side. So where is 2? Okay, 2 is somewhere here. So as soon as I draw this line here, this becomes the positive, this becomes the negative. So I need to look at the graph on the right and the graph on the left. And then I need to trace it along this line here. So this is positive. So I need to have this graph on the positive to the orange line, and I'm getting here. Then I need to trace this one to the y-axis and have minus 1. So I'm going to have this one to be minus 1 here. Then on the left, we have this graph on the left. So I need to be going along this to the line that I have here and go to the y-axis, which is also 1. So this is going to give us minus 1. So what will be the conclusion for this? This does not exist because this and this are not the same. Or in other terms, we have a jump discontinuity here. Now let's look at 3. Sorry, minus 3. Where's minus 3? Okay, minus 3 is here. So minus 3 is somewhere here. Now for us to talk about minus 3, we need to look at the left and the right of the graph. So this is the right and this is the left. So the right and the left are all converging at one point, and it's giving us 2. So the left is 2, the right is 2. So therefore, this is going to be 2. Very simple from there. Now let's look at 4 from the positive and then from the negative. So where's 4? Okay, so I can see 4 somewhere here. Good. So from the positive side, we see that the graph is approaching it from the positive side, and we are going to negative infinity. So this is equal to negative infinity. And when we are approaching this line from the left, we move to positive infinity. So this is going to give us a positive infinity, which is very simple. So always, even these ones are very simple than when you are trying to sketch. But the sketching sometimes is very difficult than you trying to figure out the limits. All right. Now let's do the last question. Now I brought the last question here, which is question 1, because this question 1 is basically almost the same as the 4 2023, because the 4 2023, this one was 10 and now this one is 4. So it means that we're going to get the same results, right? So I'll just go through quick and then we are done. So we are using the formula here, right? So what we just need to do is I'm going to assign T1 here and then T2 here. So the average rate of change is going to give us f of 3 minus f of 1 divided by 3 minus 1. Let us look for f of 3 using the function given to us here. So this is going to give us 3 squared plus 4. This is 9 plus 4, and this is equal to 13. F of 1 is equal to 1 squared plus 4. This is 1 plus 5, and this is, 1 plus 4 is 5. So this is going to give us 13 minus 5 divided by 3 minus 1. And this is going to give us 8 divided by 2, and this is 4. So you see that we have gotten the same result for 2023. Now, we want to look at when T1 is 1 and T2 is equal to 1 plus h. So this is going to give us f of 1 plus h minus f of 1 divided by 1 plus h minus 1. So we are using the same function, and f of 1 was given as 5. So we don't need to worry ourselves for f of 1. We need to try to figure out f of 1 plus h. And this is the same as what the function t squared plus 4. So this is 1 plus h squared plus 4. This is the same as 1 plus h plus 4. And then when you expand this one, you are going to have 1 plus 2h plus h squared plus 4. And this is the same as 2h plus 5. No, plus h squared plus 5 rather. So this is going to give us 2h plus h squared plus 5, which is for this here. And this is equal to 5. So we are going to have minus 5 divided by h, because this, let me write it well, this is 1 plus h minus 1. So this is going to give us 2h plus h squared divided by h, because this will cancel this. And we are going to have h out, 2 plus h divided by h. And this is going to give us this. So I think this is the same as, because we are just changing the constant from 10 to 4, we are getting the same results. So here we look at h is approaching 0 of the final answer that we got here. We set h to 0, and this is equal to 2 plus 0, and this is equal to 2. So this is what you are going to get for the question here. All right, so in the next video, we are going to look at for 2024, right? Last video on for 2024. Then I wish you all the best.